everyone, and welcome to MathSux. This video is going to help you pass the Geometry Common Core Regents. We're doing this one question at a time. Here is question 1. A square pyramid is intersected by a plane passing through the vertex and perpendicular to the base. Which two-dimensional shape describes this cross-section? So if we have our pyramid and we imagine that we're intersecting with a plane, kind of like cutting this, you can imagine that we're going to end up with a triangle. So if we kind of just take a piece of this flat image, we're going to get a triangle, which is choice number 2. Question 2. Trapezoid ABCD is drawn such that AB is parallel to DC. Trapezoid A'B'C''D' is the image of trapezoid ABCD after a rotation of 110 degrees counterclockwise about point P. So that means that these are also going to be parallel. Which statement is always true? So if you go through these, you'll see that they don't really line up, angle A being congruent to angle D prime. So that's not our answer. Choice 2, AC, so a diagonal AC would be congruent to BD. So this is also a diagonal, but this is on the short side, and notice this goes to the longer side, so that's not the answer. And then choice 3, A prime B prime is going to be parallel to D prime C prime, which we marked on our paper already, so we know choice 3 is our answer. Question number 3. What is the volume of a right circular cone that has a height of 7.2 centimeters and a radius 2.5 centimeters to the nearest tenth of a cubic centimeter? So let's draw this. We have a cone. It says the height is 7.2 centimeters. And then the radius is 2.5. So we just need to remember the volume of a cone, which is pi r squared h over 3. And then we could just plug this in. So we know the radius, r squared, is 2.5. And then the height is 7.2 over 3. We could just plug this into our calculator. And we get about 47.1, which is choice number 2. Question number 4. In the diagram below a right triangle sun, where angle N is a right angle, SU is 13.6 and SN is 12.3, what is angle S to the nearest degree? So let's write out SOHCAHTOA. We know we're going to be using that because we have a right angle. And we want to find angle S. So to angle S we have the adjacent and the hypotenuse. So we know we're going to be using cosine. So we have cosine of theta, angle S, is equal to the adjacent, which is 12.3, over the hypotenuse, which is 13.6. So to do this, we're just going to do arc cosine of 12.3 over 13.6 and plug this into our calculator. So to do like second cosine, and then just plugging in 12.3 divided by 13.6. And we get 25.25 degrees, which is closest to choice 1 with 25 degrees. Question number 5. In the diagram below of circle O, diameter AOB and chord CB are drawn and angle B is 28 degrees. What is angle BC? What is arc BC? So we're trying to find arc BC, which is over here. So before we try to find that, notice that we have this diameter here, so we know that the circle is split in 2, and that this whole section here is going to be equal to 180 degrees. So they gave us one angle, and because this is an inscribed angle with an intercepted arc, we know the rule for that, where the angle is equal to half the intercepted arc. So our angle is 28 degrees, and we know it's going to be equal to half of arc AC. So this section over here, AC, we can find is the intercepted arc. So we're just going to multiply 28 times 2, and we end up getting 56 is equal to arc AC. So if you know that over here is 56 degrees, we can find what's left by subtracting 180 minus 56 degrees to find out what arc CB is. And we get 124, which is choice 2. Question number 6. In the diagram below of parallelogram ABCD, diagonal BED and EF are drawn. EF is perpendicular to DFC. So if we know it's perpendicular, we know we can have a right angle here. Angle DAB is 111 degrees and angle DBC is 39 degrees. What is angle DEF? So we're trying to find this angle right here. So because this is a parallelogram, we know we can find these other angles. So if this side is 111 degrees, its opposite side is also going to be 111 degrees. And now notice we have this triangle in here, 39, 111. So we can add up 39 plus 111 and then subtract this number from 180 to find the value in here, which is 30. Okay, so now notice we have this triangle in here. We know this is a right angle, so we have a 90 degrees plus a 30 degrees plus the angle we're trying to find plus this unknown angle is going to equal 180 degrees. So let's solve that. 180 minus 90 plus 30 equals 60. Choice 3. Question number 7. In the diagram below of triangle ACT, ES is drawn parallel to AT. So let's just draw in our parallel lines such that E is on CA and S is on CT. Which statement is always true? So we're going to base this answer on the triangle proportionality theorem. So what this is saying is if a line parallel to one of the sides of the triangle intersects the other two sides of the triangle, then the line divides these two sides proportionally. So this almost looks right, but it says CE, the short top side, over CA, which is the long side. So that's not right. CE to ES, so that's not right. We're not involving ES or AT. And then this choice number 3 here, CE over EA is equal to CS over ST. This is our answer. So just to show you why, when you have CE, it's over here. EA is over here. And then this is going to be equal to CS, this side, to ST, this side. So we have all our sides lined up perfectly, which is what we want and what the triangle proportionality theorem tells us. Question number 8. In the set of axes below, congruent triangle ABC and DEF are drawn. Which sequence of transformations maps ABC onto DEF? So we're taking triangle ABC and we want to map it perfectly onto DEF. So the first thing I notice is that it looks like we're doing a counterclockwise rotation of 90 degrees. And if you look at the answer choices, they almost all have this a counterclockwise rotation of 90 degrees first. So let's look at that first. So the rule for this is a point becomes negative y x. So if we look at point A, and then we rotate it, the counterclockwise rotation of 90 degrees about the origin, we're going to switch the x and y, and then negate the y. So this A will now become -6.2. So actually let's do that with all the points. So we could connect our dots, and you see that we're right in line with the triangle DEF, which is what we're trying to map onto. So in order, the next step to map onto this, we just need to translate it. It looks over a couple units to the right. So let's count how many units to the right we need to go over. So this is definitely part 1, or counterclockwise rotation of 90 degrees about the origin. So we can cross off number 4 because it says a clockwise rotation, which we don't do here. So let's see, we know A is going to become D, so let's see how many points this takes. So this, we need 8 units to the right. And this first answer choice here has followed by a translation 8 units to the right, so we know choice 1 is our answer. Question 9. An equation of a circle M is x squared plus y squared plus 6x minus 2y plus 1 equals 0. What are the coordinates of the center and the length of the radius of circle M? So let's write this out. We're going to be completing the square here 2 times. So the first thing I'm going to want to do is combine the x values together. So not combine, to reorder this equation so the x's are together. So we have x squared plus 6x and that the y's are together. Plus y squared minus 2y. And then we're going to move this to the other side by subtracting, so minus 1. Now we're going to divide this number by 2. So we're going to complete the square 2 times, so first with the x's, then with the y's. So to complete the square with the x's, we're going to divide this by 2. And we are going to rewrite this as x plus 3, the number you get here when you divide by 2, squared. And then over here we're going to do the same thing, divide -2 by 2, you get -1. And we'll come back to these numbers later. So now we'll rewrite this as y minus 1 squared. And then those numbers that we circled, we're going to add on the other side. So plus 9 and plus 1 that we squared. Now we have x plus 3 squared plus y minus 1 squared. And then notice these 1's cancel out and we're left with 9. And the center is going to be the opposite signs of this. So this is a positive 3, so this is going to be minus 3. And this is a minus 1, and it's going to become regular 1, positive 1. And then the radius is always the square root of the number to the right of the equal sign, which will just be 3. So now let's look at our answer choices that we have here. -3, 1, and radius of 3. Our answer choice 4 is our answer. Question number 10. Parallelogram Beth with diagonals BT and HE is drawn below. Which additional statement is sufficient to prove that Beth is a rectangle? The answer here is choice number 3, BT is congruent to HE, because all rectangles have congruent diagonals. Question number 11. A gardener wants to buy enough mulch to cover a rectangular garden that is 3 feet by 10 feet. One bag contains 2 cubic feet of mulch and costs $3.66. How much will the minimum number of bags cost to cover the garden with mulch 3 inches deep? So we have this, it says rectangular, but it really sounds more like a rectangular prism that we have to fill. So something like that, where it's 3 feet by 10 feet. And then it's telling us the price of the bag, but it also says that this is feet, and then this is 3 inches deep. So this is going to be 3 out of 12 feet, because we want to keep the same unit of measurement. So this is inches, and then we have feet and feet. And then we're dealing with feet again with the mulch. So if we multiply all of this together, this will give us the volume of the garden that needs to be covered. So we get 7.5. So that means the volume of our garden is 7.5 feet Now we need to find out how many bags we're going to need. So to find out how many bags, we're just going to take 7.5, our volume, and divide it by the volume that's within each bag. So there's 2 cubic feet within each bag. So we're just going to do 7.5 divided by 2, and we get 3.75. So we can't get 3.75 bags, we can only get whole bags, 3 bags, 4 bags. So what we're going to do is round up. So we're going to get 4 bags to fill our garden, because we're going to need 3 bags plus 0.75 more bags. So we have 4 bags, and then now to find the price, we're just going to take 4 bags times the price, which is $3.66. Multiply it together. So we have 4 bags times the price, $3.66, and we get 14.64. And that's how much this is going to cost, which is choice number 3. Question number 12. In the diagram below, triangle DOG is similar to triangle CAT, where angle G and angle T are right angles. Which expression is always equivalent to sine of D? So here's D, and sine of D, we write at SOHCAHTOA. Sine of D would be GO over here over the hypotenuse. So notice that the side we're working with is like the shorter side over the hypotenuse. So when we're looking at this, we're looking at triangle CAT. We're gonna try and see what's equal with the shorter side over the hypotenuse. So if we look at cosine of A, over here we're dealing with the adjacent, which is right here, which if you look at the 2 lengths of the side, this is the shorter side. And then over the hypotenuse, CA. So this, right away, choice 1 is our answer. Question 13. On the set of axes below, triangle DEF is the image of ABC after a dilation of a scale factor 1/3. The center of dilation is at what point? So we're going from ABC to DEF. So there is actually a formula for this, for finding the center of dilation. It looks something like this. So we're going to do it 2 times, once for X and once for Y, where K is the scale factor, which we know is 1/3. And then these X's are going to represent the points before dilation and after dilation. So if we're going to pick a pair of corresponding points before dilation and after dilation. So if we go from point A, which is -10, 6, notice it corresponds with point D at point -2, 0. So this will be our x1, y1, and this will be our x2, y2. And now we just need to plug this in. So K is going to be our scale factor, which is 1/3, times x1, which is -10, minus x2, which is -2, or +2, because we're subtracting, all over K minus 1, which is 1/3 minus 1. So if we plug this into our calculators, we're going to get 2. So X is going to be equal to 2. And then we're going to do the same thing for Y. So this time we have K, so the same scale factor, times Y1 minus Y2 all over K minus 1. So here we'll get 1/3 again for K, the scale factor, and then Y1 is 6, and then minus 0 all over 1/3 minus 1. And this will get us -3. So we have X is equal to 2 and Y is equal to -3, which is choice number 2. Question 14. In the diagram below of isosceles triangle AHE, so first let me just mark, so we have an isosceles triangle, so we know that these angles are going to be equal and these sides are going to be equal too. With the vertex angle at H, CB is perpendicular to AE. So CB is perpendicular to AE, so let's mark that. We can make a right angle here. and FD is perpendicular to AE also, so we can write a right angle there also. Which statement is always true? So let's go through each of these and see what makes sense. So actually, before I even do that, let's look at these two triangles. Within here we have triangle ACB and triangle FDE. And notice that these two triangles are similar by angle, because this is an isosceles triangle, so angle E is congruent to angle A, and we have these two right angles here, one for each triangle. So these two triangles are similar. So we're going to be looking for something where the two triangles are in proportion to each other. So if we look at answer choice 1, it starts with AH over AC. So already this is wrong because we're using the original triangle AH, this length here. So we know that's not the answer. Choice number 2, AC. Okay, so now we're working with our triangle AC, the hypotenuse is congruent to EF, the hypotenuse of the other triangle. Okay, this looks good so far. And this is equal to AB, the shorter leg, over ED, the other triangle shorter leg. So this is actually our answer, choice number 2. Question 15. Rectangle ABCD has two vertices at coordinates A, -1, -3, and B, 6, 5. The slope of BC is what? So we can graph this out on our paper here, just like a little sketch. So if A is -1, -3, it's about here, and B is 6, 5. That's about here. So we know that this rectangle has two vertices at coordinates. We know that this is going to connect like this. And since it doesn't give us much information on how this is drawn, so I'm just going to guess and kind of sketch it this way. So we could say that CD is somewhere in here. So the slope of BC is what? This slope is what? Remember, with a rectangle, we have 4 right angles going all around in each corner. So if we have the slope of A and B, we'd be able to take the negative reciprocal of that to find the slope of BC because of the right angle that is here. So if we just find the slope first between A and B over here, we can then flip and negate that slope and find the slope of BC. Okay, so let's find the slope of AB first. So now we just need to take the negative reciprocal of that. So we're going to take 8/7 and then flip and negate it, so it would become -7/8, which is choice 1. Question 16. In right triangle ABC, angle A equals 90 degrees, angle B equals 18 degrees, and AC equals 8. To the nearest tenth, the length of BC is what? So I could tell this is going to be a SOHCAHTOA problem. So first let's draw out our triangle and what they tell us. So we know angle A is 90 degrees, angle B is 18 degrees, and AC equals 8. So now we want to find the length of BC, which is the hypotenuse. This is what we want to find here. So if we're working with angle B, we have the opposite and we want the hypotenuse. So we have opposite hypotenuse. We know we're going to be working with sine. So sine of 18 degrees is equal to the opposite 8 all over the hypotenuse, which we don't know. So now we could just do some cross multiplying. And we could just plug this into our calculator. And we get 25.9, which is choice number 4. Question 17. The measure of one of the base angles of an isosceles triangle is 42. So let's first draw the isosceles triangle. and we're saying one base is 42. And we know that the other base is also going to be 42. And because of that, we can actually find the vertices of this angle, which is 96. Okay, so we have this. We're ready for the next part of this question. So the measure of an exterior angle at the vertex of the triangle is what? So if we were to draw an exterior line as if this triangle kept going, we want to know this exterior angle here. So we know that this is a line, so we know this is going to have to add up to 180 degrees, this whole thing here. And if this part is already 96, we're just going to subtract that to see what's left. And we get 84, which is choice 2. Question 18. In the diagram below, AFKB is parallel to CHLM. FH is congruent to LH, and FL is congruent to KL. LF bisects, so here's LF, bisects angle HFK. So HFK, this is bisecting, so these are equal to each other. What statement is always true? Okay, so let's look at this one at a time. So this first answer choice here says 2 times HLF, 2 times angle HL. So we're looking at over here is equal to CHE. So 2 of these are equal to CHE over here. So no, choice 2. 2 times FLK, so 2 of these guys, is equal to LKB to this. So that's also not our answer. Choice number 3. Angle AFD, so over here, is equal to angle BKL, so over here. So that's a no, there's no angle relationship going on there. And so by process of elimination, it has to be number 4. But let's just look at why. If we look at angle DFK, so I'm gonna, since this is our answer, I'm just gonna highlight it in pink over here. We're saying that that's equal to KL. So this is tricky, but the reason this works is because if you look at this, we know that this bisects the angle over here, and we know that these 2 lines are parallel. Because this is a transversal, cutting up 2 parallel lines, we know that this angle is also equal to this angle, and we also know this angle is equal to this angle, because these 2 line segments are congruent. And this line over here is also cutting the parallel lines, AFKB. So we know that all of these are equal to each other. So if you notice the pattern here, we have these 2 equal angles and then the pink. And then we have these 2 equal angles and then the pink. So, and then what's left over. And they're both sitting on a line. So whatever is left over in the pink, they have to be equal to each other. So it's kind of confusing to look at. Please let me know if you're thinking about this a different way. I'm just like talking about it visually, but that's how I got this question. Question number 19. The line whose equation is 6x plus 3y equals 3 is dilated by a scale factor of 2 centered at the point 0, 0. An equation of its image is what? So since it's centered at point 0, 0, we know we're going to be keeping the same slope. So let's find the slope of this first. So we're going to keep this same slope. So right away we can get rid of answers 3 and 4. And then we're going to be using the scale factor of 2 to multiply the y-intercept. So the y-intercept is 1 times the scale factor, which is 2. Will just give us 2, and we'll get this new dilated equation of negative 2x plus 2. And whenever you dilate an equation, the slope is actually always going to stay the same. So just remember that. The slopes will always be parallel to each other. From the pre-dilated equation to the now dilated equation, the slope will always be the same. Question 20. Which figure will not carry on to itself after a 120-degree rotation about its center? So when we think of an equilateral triangle, that's 180 degrees divided by 3, which gives us 60 degrees, which is, easily divisible by 120. So this will carry on to itself pretty easily. So that's a no, not our answer. A regular hexagon has 6 sides. So we're taking 360 degrees, dividing it by 6 sides. And we get the same kind of thing. We know it's going to rotate onto itself again because it's divisible by 120. And then we have a regular octagon. This has 8 sides. So 360 divided by 8 gives us 45, which is not divisible by 120 evenly. So we know that 3 is our answer. And if you looked at the nonagon, which has 9 sides, you'll see that this divides evenly by 120, because 120 divided by 40 would be 3. So this isn't our answer either. So choice 3 is our answer. Question 21. Triangle ADF is drawn and BC is parallel to DF. Which statement must be true? So here, when they're parallel, we're kind of treating these like they're transversal. So let's look for something with angles. And the only thing with angles here is choice number 4, where it says angle ACB is congruent to angle AFD, which is true based on these being parallel lines and AF acting like a transversal. So choice 4 is our answer. Question 22. In triangle ABC, M is the midpoint of AB and N is the midpoint of AC. If MN equals x plus 13 and BC equals 5x minus 1, what is the length of MN? So let's sketch this out. So we're going to solve this using the triangle midpoint theorem. So this states that a line segment in and adjoining the midpoint of any 2 sides of the triangle is parallel to the third side and is half the length of the third side. So knowing this, we can write out 2 times x plus 13 is equal to 5x minus 1, and then just solve for x. So x isn't our answer though, 9 is not our answer. They want to know the length of MN. So MN is x plus 13, which we now can plug in 9, and we get 22. So our answer choice here is choice number 4. So yeah, if you want to review the triangle midpoint theorem, please look that up. Question 23. In the diagram below of isosceles trapezoid star, diagonals AS and RT intersect at O, and ST is parallel to RA, with non-parallel sides SR and TA. Which pair of triangles are not always similar? So there's 3 different ways to prove that triangles are similar. And that's angle, angle, side, 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 or side, angle, side. So that's what we're going to be looking for in each of these examples. So let's look at this first one, triangle STO. So STO up here with triangle ARO over here. So let's see if we can prove these. You have these vertical angles, and then because these sides are parallel, it's going to form all these angle relationships. So right away we can prove these 2 triangles true by angle, angle. So that's not our answer, because we're looking for something that's not similar. Okay, let's look at choice number 2. Triangle SOR over here and triangle TOA over here. So again, we have vertical angles. If you look back, it does say that this is an isosceles trapezoid, so that means that this side is going to be equal to this side. So we have a side and an angle, and then can we find another side? So because this is an isosceles trapezoid, there's other reflective relationships going on here. So because these sides are equal, there's also these equal diagonals going on, which means each of these sides are equal as well. So this side is going to be equal to this side, and this side is going to be equal to this side. So this can be equal by and similar by side angle side, or side side side. So this again is not our answer because we can prove that they're similar. Okay, let's look at choice number 3. Triangle SRA, so this in here, is that congruent to triangle ATS in over here? So let's see what they have in common. Right away we have like this reflexive line that they're sharing, this long side, so they have one side that's equal. Their opposite angles are not equal because this isn't a parallelogram, so like this is not equal to this is not equal to this. They do have another side because this is an isosceles triangle, so we have 2 sides right now, but we know that these two aren't equal because this is a trapezoid, RA to ST. So this is going to be our answer. Choice number 3, we can't prove as similar. Question number 24. The endpoints of AB are 0, 4, and negative 4, 6. Which equation of a line represents the perpendicular bisector of AB? So if we're doing perpendicular bisector, we know we're going to be flipping and negating the slope of AB. So first, let's find the slope. So it's just the change of y over the change in x. So the slope, let's see, so we have 0, 4 and negative 4, 6. So we get negative 1/2, but we want to flip and negate it because we're getting a perpendicular bisector to it. So if we take the negative reciprocal, which is flipping and negating, we're going to get 2. So okay, so we have our slope, but how do we get the rest of this equation? So really careful here. This says the word bisector, so that means we're going to be bisecting this line AB at the midpoint. So we're going to be making this perpendicular bisector, a line that cuts AB in half and forms a right angle. That's what a bisector is. So to get this point of the bisector, we're going to find the midpoint. And to do that, we just end up taking the average of both points. So we're just going to take, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So here are x1s and x2s, so we're just going to do negative 4 plus 0 divided by 2, and then we have 6 plus 4 divided by 2. So we get negative 2 and 5, and now we're just going to write out our equation of a line. So equation of a line is mx plus b, and now we're just plugging everything that we have. So we have y is 5, m is 2, we found over here, and then we know x is negative 2, and then we're doing this to find b, the y-intercept, which we don't know yet. So we end up getting 5 equals negative 4 plus b, add 4 on both sides, and we get 9 is equal to b. So now we have everything to write our equation of a line and fill in our answer. We have y equals the slope 2, x plus the y-intercept b, which is choice number 4. So we finally finished part 1. Look out for part 2 coming out soon. Good luck on your test and happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!